Hello, Math 1. So this is the Module 2 review video. Remember, this is the one we're doing in class together, and these are considered your notes. So these are due before class, Monday, November 23rd. November 23rd is when we are taking our test. So please make sure you do this and watch this video. I'm going to be talking a little bit faster in this video, so remember you can pause and rewind and do all that fun stuff. So here we go. Equations we've seen this module. So we've seen linear equations. Now the first one I'm going to talk about here is slope-intercept form, which is f of n is equal to m times n plus b, where m is the slope and b is the y-intercept. That's just a fancy word of in our graph where our graph passes through the y-axis. If it passes through the y-axis, it's this thing called the y-intercept. So what do you need to use in order to write with this equation? What do you need to use it to write the equations? That sounds weird. So our m value here is the number we add or subtract by in our table. I needed to finish that out here. And then, so if that's for the table, in a graph, it's our slope. It's how we go up and over in our graph. Now the b value is the number we begin with on the right side of our table. And then for a graph, it's the number we begin at on the y-axis for a graph. Oops, and that's a little bit hard to see, so I'll move that for you. Looking at this particular equation, we have f of n is equal to 1/2 n plus 4. When I look at this, I see that my m value here, my m value is equal to 1/2. Right? That's the number in front of my n. The number in front of my n is my m value. It's my slope. Okay? My b value is equal to 4, right? This is a positive 4, so this is a positive 4. Now be careful here, because you need to use that sign that's in front of it. So this would have said a -4, then our b value would have been a -4. So be careful with that. 1/2, 1/2. All right, point slope form. So this is the one we learned most recently. This is f of n is equal to m times n minus a plus b, where m is the slope and a, b is the coordinates of a point on the line. Now here's something super duper important, okay? See how this says a minus a here? But then when we write that point, it becomes positive. So you almost want to think of this as a lying little kid, right? This lying little kid had to stay inside of this parentheses. We'll pretend this parentheses is a house. This little kid had to stay inside because he lied to his mama. So we have to assume he's lying all the time now. So when we rewrite this number as a point, we do the opposite of what it says. So if this says negative a, we're going to use a positive a when we write this point. But this kiddo, this positive b here, well, he's a truther, right? He got to go outside and play. He didn't lie to his mama. So we get to just do exactly what he says. If he's a positive b, then when we rewrite him as a point, he's still a positive b. Now let's make sense in our example here. But first things first, this m in our point slope form is our slope from a graph, or the number we add or subtract by, again, in a table. The b value here is the point from our graph, or it's a point on our table. So let's look at our example. We have f of n is equal to 1/2 times the quantity n minus 4 plus 3. So let's figure out our m value here first. Well, luck would have it, this m value is the same as the one before. It's 1/2, right? That's that number in front here. Let me get my highlighter so you guys know what I'm talking about. Here's that 1/2. Here's that 1/2. Now we're going to figure out our point. So our point is going to be, let's see what we have here. We have a -4 and a +3. So this guy on the inside, like I said earlier, He's a liar. He lied to his mama. That's why he's inside. So we have to do the opposite of what he says when we write out the point. Now, what do you mean by that, Miss Rolfe? Well, that means that in the point here, I'm going to have a 4, a positive 4. Not this negative shenanigans that he's saying on the inside here, because again, he lied to his mama, so we got to assume he's a liar, liar, pants on fire. But number 3 on the outside, this positive 3, well, he didn't lie to his mama. That's why he's playing outside. So we can do what he says. So if he says he's a positive 3, then I can say that he is also a positive 3 when I write him out in my point. Okay? I hope that helps you. I know some of us struggled with that concept. So let's move on to the next bit. Okay, so next thing we have are the equations we've seen for an exponential. So let's look at this explicit form with no percents. Okay, let's look at this one first. So when we look at this one, we have f of n is equal to a times b to the exponent n, where a is your initial value and b is what you multiply by. So what do you need in order to write this equation? Well, on a table, it's your start number on the table, and right on the top right. Or if you're on a graph, it's the number on the y-axis for a graph. Your b value is the number you multiply by down a table or a graph. Because remember, when we were writing out the equations from a graph for an exponential, we still made a table. So let's look at this first example. We have f of n is equal to 10 plus 3. I'm sorry, 10 times 3 to the n. Miss Rolfe cannot read. So what's my a value here? Well, my a value here is 10. So I'm going to write that in here. What am I multiplying by? What's my b value? Well, my b value right here is a 3. Easy enough. Explicit form with percent, so the ones we've been struggling with, right? So we had 2 of them. We had f of n is equal to a times the quantity 1 plus r to the exponent n, and then we had f of n is equal to a times 1 minus r to the exponent n. Okay, now this is if we have a increasing percent, that's when we add our r. This is when we have a decreasing percent and we subtract our r. Now your a value is your start value in a word problem, because it's the only time we really saw percents was with word problems. Now r is your percent, which you must change to a decimal. Now I have provided 2 options. You can either divide by 100, you can take your percent, divide it by 100, or let's say if we have 37%, right? If you want to change it to a decimal, start at the back, move to the left 2, and that's your new decimal place. So this would change into 0.37, okay? Those are your 2 options. Both of them would give you the same answer. So let's look at this middle example here. F of n is equal to 10 times the quantity 1.25 to the exponent n. Well, my a value here is 10. Now my r value here, this is where it's going to get a little bit crazy, right? So you're just going to have to go with me on faith. Well, this has to be 1, right? Because it has to have a 1 in it. So it has to be 1 plus 0.25, right? That's the only way we would get a 1 and some other number that would turn into 1.25. So my r value is 0.25. Now looking at the second one here, we have 10. That's my a value, right? So if this one was 1 plus, well, this one's 1 minus something, right? Because this is a number less than 1. And in this case, again, you're just going to have to go with me on faith, but this is 0 minus 0.25. So my r value here is a minus 0.25. I'm sorry, my r value here is 0.25. So we have the same information written out on this far right side, but we have 2 kind of different equations. It depends on if you have an increasing percent, right, where you have a value greater than 1 inside, or if you have a decreasing percent, which you have a value less than 1 inside. Okay? So, moving on. All right, so in his job selling vacuums, for example 1, Joe makes $500 a month plus $20 for each vacuum he sells. Write an equation that describes Joe's monthly income. Okay, well, we know that Joe, if this says plus 20, he is going to be adding, right? He's going to be adding $20 every month, right? And if he's adding, well, that makes it a linear equation, right? And the linear equation we're going to use is we're going to use f of n. So we're going to use f of n is equal to mn plus b. Okay? And no matter what, Mr. Joe here, every month he's going to start with $500. Okay? Right? No matter what, it says he makes $500 a month. Now, if you're like, "Ooh, I'm not sure if I'm going to remember that we're going to use the table," we're going to use this particular equation I have written here. Well, you can also just write this as a table, which, we should hopefully be comfortable with now. So Mr. Joe, no matter what, he's going to start with 500. If he sells one vacuum, well, then he gets $20 more. So if he's going to add by 20, so that makes his new value in the table here $520. If he sells two vacuums, right, well, that means he's going to add another $20 to his monthly income. So now he's at $540. Okay, so if you don't know that you need to use this equation, maybe write out the table. Okay, so looking at this equation now that we're speaking of it, it's going to be f of n is equal to, your m value is the amount that you add by every time he sells a vacuum. Well, in this case, that's 20. N stays an N, that don't change. And then he starts with 500. So that's my B value. He starts with 500. Okay, so name the form of the equation you chose and why you chose that form. Well, we were smart young people and we chose the slope-intercept form. Miss Rolfe is very smart writing orange on orange. Because, and I'm going to abbreviate because we were given a beginning value, and that beginning value in this case was 500, and we added by 20, right? That adding by 20 tells me I'm using some type of linear, but because we are given a beginning value 500, that tells me use slope-intercept form, right? We were given a beginning value and we were adding. So this is a linear function because we add. Now, this is something we learned on Monday. This is going to be discrete, continuous, or neither. Well, beautiful young people. This is going to be discrete. Why? He sells vacuums. You can't have half of a vacuum. Okay? You count the number of vacuums you sell. It's not a continuous. Next problem. Example number 2, we're going to write the equation of a line with a slope of 1 through a point -2, 5. All right, so we're given a slope and a point. So this means that we're going to use point slope form. Which is f of n is equal to m times n minus a plus b. So let's figure out some information here. Well, our slope, we are told, is -1. So on the side over here, I'm going to write that m is equal to -1. Okay? My point is -2, 5. So now this -2, that's my a value. This 5 is my b value. So I'm going to plug these into my equation here. So we get f of n is equal to -1, that's my m value, times n minus a -2, because that's my a value, plus 5, that's my b value. But it's not okay. It's not okay for us to write -2. Right? Mathematicians would look at you like you're crazy. So 2 negatives, remember, make a positive. So when I rewrite my equation here for my final answer, I get f of n is equal to -1 times n, Miss Rawolf, n plus 2, close your parentheses, plus 5. Final answer. No ifs, no ands, no buts. So name the form of the equation you wrote. Why did you choose it? Well, we chose point slope because we were given a point and a slope. It's as simple as it gets, you folks. So, couple of things, right? This is a linear equation. And how do you know that, Mr. Rawolf? It says point slope. We don't see a table where we're adding. It doesn't tell us that we're adding. Well, because slope is only for linear. But Miss Rawolf, what about, how do we know if it's continuous or discrete? Well, it's going to be continuous because it's just an equation. Not a situation. And what I mean by situation is a word problem, right? If it's just an equation and not a situation, then you assume it's continuous. Next problem. All right, example 3, write the equation of a geometric sequence that has a constant ratio of 5 and a first term of -3. Well, first things first, beautiful young people, this word geometric here, that tells me that we're multiplying by something. Well, I either have to be multiplying by 5 or -3. Well, how do I know which is which? Well, this says that my first term is -3, a first term of -3. So if I had a table going on here, when I read that, it means my first term is -3. That's what it's saying. So that only leaves the only possibility of what we're multiplying by is this constant ratio. It's a constant ratio of 5, and I didn't want to do that in green. I wanted to do that in purple. I want to do that in green. So that means we are going to be multiplying by 5 down our table, right? So if we're multiplying by something and it's not a decimal, if you know off the top of your Chrome Dome, which is good to know, we're going to be using this equation, f of n is equal to a times b to the n, right? So my a value is my start number. Well, in this case, my start number here is this -3. So I'm going to write that -3 times our constant ratio using vocab word. Well, that constant ratio is what we multiply by, that 5. And then we have this exponent n. But, I know, what was our first number on our table? It's a 1 here. It's not a 0. So that means we got to write to the n-1. Okay, so be careful about that, right? If it starts with 1, it says that word first, right? Then you have to use n-1 in your equation. So, final answer here. So, name the form of the equation you chose and why. We used the explicit no percent equation because we multiply by 5 and start with -3. So we multiplied by 5 and started with -3. None of those are percent numbers. So, is this function linear, exponential? Neither. It's exponential. Why? Because we multiply. Is this discrete? Is this continuous? Is this linear? Now, whoop, there's this fancy word, geometric. It's a geometric sequence. geometric and arithmetic sequences are always discrete. Okay, so because it said geometric sequence, be careful with that. All right, next problem. Example 4, write the equation of the function graphed below. So first thing you want to do here is you see if you can find where the graph passes through the y-axis nicely. And remember, this up-down line here is your y-axis. So where does my thick line here pass through at? Well, it does pass through a nice number. It passes through right here, and that's -3. So that means I'm having a b value of -3. Now, because we can see where it passes through at a nice number like this, we're using that slope-intercept form equation. F of n is equal to mn plus b. So I got my b. Now I got to figure out my slope, my m value here. So what I'm going to do is I'm going to follow my line, and I tend to go to the right because I read left to right. I'm right-handed. I go to the right. So I'm going to start at this point, and I'm going to follow this line until I see where my graph passes through a grid's intersection. Well, that's right there, here. And it doesn't matter where you find it, as long as you find it correctly. That's kind of important. But even if you didn't see this one and kept going, you should end up with the same answer. Okay, every single class, no matter what, I do that. All right, so here's my point. So I have to figure out how to get from my blue dot to my green dot, okay? And that's going to be my slope. So how do I move up or down? How do I move left or right? So in this case, right, I go up 3, and going up 3 is a positive number. And remember, the top of your fraction is if you go up or down. And then, I go to the right 4. Going to the right 4 is positive. Going to the right or left is the bottom of your fraction. So I'm going to just rewrite this all in green. So I got 3/4, right? So when I write my equation out, I got my m value, got my b value, write this all out. I got f of n is equal to 3/4 n plus -3. Hold up. Wait a minute, Miss Rawolf. It is not okay for us to write plus -3. Mathematicians would laugh at us. So if I can't write it as plus -3, I have to rewrite it as f of n. Let me write this correctly. F of n is equal to 3/4 n minus 3. Okay? A positive and a negative make a negative. So name the form of the equation that we used. Well, I kind of said it earlier, so I gave it away, but we used slope-intercept because we could find our beginning point on the y-axis and counted to find our slope. If we weren't able to find that first blue dot I wrote out, then you would have used point slope form. All right, so hold up, wait a minute. This graph is a straight line, so that means it's either linear, exponential, neither. Whoop, it's linear because it's a straight line graph. Is this function continuous, discrete, or neither? Hold up. Do we remember this is continuous, right? Because it's a line rather than just dots. Just dots would be discrete. All right, next problem. All right, example 5. The population of the resort town Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 3%. Write an equation that models the number of people in Java Hot Springs. So this is a multiplying equation, and this is going to be one of those equations that uses an R, right? But because it says it's an increase of about 3%, then we're going to use f of n. So we're going to use f of n is equal to a times 1 plus r to the n. So we need to figure out our a value. Well, we began with 35,000 people. So A is 35,000. Now, our R value is the percent here, 3%. But we have to change this 3% into a decimal. Now, you can divide by 100, or you can move a decimal over. So I start at the back, move the decimal over twice. And that in that space there, we're going to put a 0. So we get 0.03. Don't forget about that fancy 0 there. If you forget it, you're going to get something totally different. So we have 0.03. But 0.03 isn't what we end up adding by, right? No. We have to figure out what 1 plus r is. Well, we have 1 plus 0.03, and that turns into 1.03. So that's what we multiply by. So when we write out our final answer for the equation, we get f of n is equal to 35,000. I hope that makes you guys laugh. 35,000 people times 1.03 to the n. Final answer. Whoop. So name the form of the equation you wrote and why you chose that form. Well, we chose the explicit with percents because we have a start value and a percent. Okay. Now, if we have 35,000 times 1.03 to the n here, then that means that this is an exponential problem, right? We're multiplying and we see a percent. So a couple of things. It's asking if this function is continuous, discrete, or neither. Well, our book, yes, you technically have a book. This says it's continuous because the number of people, and abbreviating people, doesn't happen all at once, right? Not all of a sudden hundreds of thousands of people are moving to Java Hot Springs. They probably trickle in continuously throughout the year. However, there's a case to be made that this is discrete because we're talking about people. You can't have part of a person. You can't have part of a person. So either one, I don't think you'll have one like this on your test. That would just be wrong. But either of these I would consider correct. All right, next problem. Last word problem, example 6. Jessica's science fair project involved growing some seeds to see what fertilizer made the seeds grow faster, and she used an energy drink to fertilize the plants. Gross. Below is the data that shows the growth of the seed each week. Write an equation that models the growth of the plant over time. Okay, so the first thing we're going to do is we got to figure out what type of equation we're going to use by looking at how we move down the table. Now, it may not be obvious at first, right? Because as soon as some of us see decimals, we go, decimals. So I'm going to rewrite this as if they weren't decimals. So what if I wrote it as 17, 29, 41, 53, 65? Okay. what are we going to do in order to get from 17 to 29? That's the same as getting from 29 to 41. That's the same as getting from 41 to 53, and so on. Right? Let's think about it like that. Well, 12 works, right? 17 plus 12 gives me 29. 29 plus 12 gives me 41. 41 plus 12 gives me 53. 53 plus 12 gives me 65. So now let's change this to decimal, right? Let's change this to a decimal. I'm going to erase this. Okay, all that work for nothing. So when I look at my equation here, well, that just changes to adding by 1.2. Adding by 1.2. Adding by 1.2. Adding by 1.2. So now we are adding down this table here, right? So we have two equations we can choose from. Point slope or slope intercept form. Now, we are going to use point slope because our table doesn't start at a 0. Okay, it starts at a 1, so we're using point slope form. Now, you've used it before in module 1, but now we just gave it a name. So when I write my equation out, I get f of n is equal to, well, we're increasing by 1.2, parentheses, n minus, well, I always like to start with my start value here. So n minus 1, right? Because we started at week 1 rather than week 0. And its partner in crime is this 1.7. So I put plus 1.7 in the back. And that's my final answer. Okay, now, I kind of said this already, but we used point slope because we found slope and used a point. Used a point. Now, you literally could have used any of these rows to write your equation out, but my beautiful brain, and maybe your beautiful brains as well, I'd just rather look at the first one. I don't want to try and look at the middle and accidentally write the wrong number and just get all cranky and get the answer wrong. Now, is this function linear, exponential, or neither? Well, it's linear, right? Because we add. And this is going to be a continuous equation. Why, Miss Rolfe? Because we're talking about the height of a plant. And height we can measure. Measuring is good for continuous. So there we go. Next problem. Okay, example number 7. We're done with the word problems. Yay! So now we're going to graph. So we have f of n is equal to 1/2 n minus 5. What do you know from the equation that helps you to graph the function? Well, this first number here, that's my slope. That's 1/2. And then this back number, -5, well, that's my beginning number, right? This is where we begin on the y-axis. So I'm going to plot this dot first, right? Where you begin, that's where you want to start. So I'm going to find -5, and here it is. And you always, every single time, no matter what, I'm yelling this a little bit loud, you always, always, always start on the y-axis. Never, ever, ever, ever start on the x-axis. Then we have to figure out our movement from our slope. Well, we have a +1 up top, so that means we're going to go up 1. We have a +2 on the bottom, so we go right 2. Remember, your top number, you either go up or down. The bottom number of refraction, you either go right or left. So from my blue dot, I'm going to go up 1, and then to the right 2. And I am going to plot the dot for that. And I'll plot it in black. I'm going to do that movement again. I'm going to go up 1, to the right 2, plot a dot. Now I'm only asking you, I only want you to plot 3 dots, right? A blue dot and 2 black dots. And then, because this is just an equation, right? It's not a situation. I'm just going to draw the line of the graph. And it's not going to be great. It's not going to be amazing. But there it is. Okay, and it's a straight line as it should be. Next problem. All right, example number 8, more graphing. We have f of n is equal to 2 exponent n. Okay, so first things first, this has an exponent n, so that means it's an exponential, which means we have to have a curved graph. So that's what we're looking for. We're looking for a curved graph. Now, what do you know from the equation that helps you graph this function? Well, there's this pesky little thing here, right? We have to figure out an a value, and we have to figure out our b value, right? So this a value here, remember how usually if we write this equation out, it's written as f of n is equal to a times b to the n. Well, we're missing a number here, right? They dropped something. We can't see one of the numbers. But we have our b to the n, right? That's our 2. So 2 is my b value, right? Because it's got the exponent attached to it. But we talked about this very briefly on Monday. When mathematicians drop a number when you're multiplying something, a number you can't see is going to be a 1, right? We can't see this. But mathematicians, right? They're lazy. They don't want to write 1 times parentheses 2 to the exponent n. They don't want to do that, right? Because 1 times any number is a 1. So that 1 is where we start on our graph on the y-axis. So here's my 1. That's that pink value. Now I'm going to recommend that you make a table, right? I super recommend that you make a table. So that pink value, that 0, 1, that's what this is, right? Our f of n value, our n value is 0, our f of n value is 1. And then I'm just going to go down my table, I don't know, 3. Let's just do 3. Now we multiply by this 2. So 1 times 2, well, that's 2. 2 times 2, well, that's 4. 4 times 2, well, that's 8. So I'm going to plot these dots. We have 1, 2. So we have 1, 2. Then we have 2, 4. So I go to 2, go up to 4. Here we go. Then we have 3, 8. Up 3 to the 8. And that's all I can graph. And again, this is an equation, so I can connect my dots because it's continuous. And I'm making that curved line I'm looking for. So we're good. If you need to rewatch this problem, please do so. Moving on to the next example. Okay, so example number 9, we have f of n is equal to negative 2 times the quantity n plus 6 plus 8. Okay, so what do you know from the equation that helps you graph the function? Well, first things first, we know, can we see this color if I write it? M is equal to negative 2, right? That's this value right here. Now this is written in point slope form, so we also have to write our point, right? Now, if you remember from earlier, we do the opposite of the inside. So if this is a positive 6, well, that means the point is a negative 6. That kid lied to his mama. That's why he's inside. We have to do the opposite of what he says, negative 6. And then we use positive 8. We keep that as a positive 8 because if you think about it, this kid's on the outside. He's playing outside. He didn't lie to his mama, so we can do what he says. Or you can think about this mathematically. Point slope form, its basic equation is written as f of n is equal to m times n minus a plus b. See how this is a minus sign here? But then in our equation, we're given we have a plus. Well, the only possible way that could have been a plus is if we had n minus a negative 6. So that's the other way we would have figured out for that to be a negative 6. Okay, so those are your 2 ways. If you remember about the lying children, or if you remember the mathy way. So now we're going to graph this. So first I'm going to plot my point -6, 8. So start at your origin, go to -6 on the x-axis, go up to 8, plot your dot. Okay, so that's my first point that I was given. Now I have to deal with this slope. Well, this slope is just a -2. I need to make it a fraction in order to move because we have to have rise over run. So whenever you're given a integer number like this, -2, you just put it over 1. So we have -2 over 1. Now the movements up top here, if that's a -2, that means we're going to go down 2. And then on the bottom, well, that's a +1, so that means we go right 1. Remember, the top number of the fraction for a slope means you go up or down. The bottom number tells you to go right or left. And again, it depends on the signs. So I'm from my pink point, I'm going to go down 2. And then I'm going to go right 1. And I'm going to plot a dot. Now I'm only asking for you to plot 3 dots. So far we have 2. I'm going to repeat that movement from my black dot. So I'm going to go down 2 to the right 1. And there's my next one. And I'm going to just do one more because I prefer 4. And there we go. You just keep repeating that slope movement we have written over here. Once you have at least 3, you can draw your graph. And it should be a straight line. Remember, anything that has slope should be a straight line. Now, I'm asking this real weird question. It says, what is the simplified answer to this equation? Okay, so I'm going to show you both the mathy way and the calculator way. And I'm going to show the mathy way first because, well, I'm a math teacher. So, mathy way, we start with that original equation, f of n is equal to -2 times n plus 6 plus 8. I distribute that -2, which means I multiply everything in the parentheses by -2. So I get -2n minus 12. Nothing else changed. So everything else remains the same. That wasn't used to distribute. Combine like terms. -12 plus 5. Type that into my calculator. Miss Rowolf, that's an 8, not a 5. -12 plus 8, gives us a -4. And again, nothing else changed when I combined the like terms, so I still have a -2n. F of n is equal to this equation. Okay? And remember, combining like terms means that they have to have the same variable in the back. So -12 and plus 8, both of them don't have a variable, so that is why they're considered like terms. Okay, now I'm going to show you the calculator way. So this is my original equation that we were given on our slide. I am going to, on the calculator over here, I'm going to type that into my calculator. So I hit y equals, then I'm going to type in negative, this is the negative sign, -2, parentheses. This button right here is my variable button, and it's going to put an X instead of an N. I don't know how to make it so that it puts an N, so it's just an X. Variables are interchangeable. We can switch them out like pants, right? You can wear a couple of different pairs of pants. Then we have +6 parentheses plus 8. Double check that your equation you typed matches the equation on my screen, and it does. So now I'm going to open up a table. Now see how it says table here in blue on the graph button? Because it says table in blue on that graph button, in order to get there, I have to hit the blue button first, then that graph button in order to get to the table. And here's my table. Now all I care about is when my left column starts with 0 and its partner. So this left column starts with 0, its partner is -4. So that's all the information I need. I'm going to rewrite this on my screen here. So copying that table, we had 0 and we had, what did I say, -4. So when I simplify this equation, now I have all the information I need. I'm going to first copy that -2 down. You always want to copy that number in front of the parentheses first. So we have f of n is equal to -2. Now, because this table information starts at a 0, I'm using just an n. And then after that, all I do is write its partner over here on the right, -4. Okay, and that's my final answer. Both of these are the exact same thing. So either way that you choose, you'll get the same method. I'm sorry, the same answer. All right, next equation. Okay, so 9, 10, and 11, examples 9, 10, and 11. I'm going to split them up into two sections. So there's going to be a calculator section, how to simplify with the calculator, and then how to simplify the mathy way. And I'm going to first start with the mathy way. So let's look at number 9 here. So we have f of n is equal to -2 times the quantity n plus 3 minus 3. So first thing you're going to do is you're going to distribute that -2 to both terms on the inside of the parentheses. And when I distribute, that means multiply. So we have -2n, because -2 times n is -2n. -2 times +3 is a -6. Nothing else changed. So everything else we leave the same. And f of n equals isn't going to change, so I'm just going to write that again. Then we combine like terms. Now, the only two things here that are going to have the same like term are -6 and -3. Like terms again, they have to have the same variable, but because -6 and -3 don't have variables, they're like terms. So -6 minus 3, well, that's a -9. If you don't believe me, type it into your calculator. -2n doesn't have a like term, so my answer is, for my final answer, we have f of n is equal to -2n minus 9. Looking at number 10 here. So first thing I'm going to do is I'm going to distribute. Let's use yellow. So I distribute that 3 into everything in the parentheses because it's in front. That's how you know. 3 times n, well, that's a 3n. 3 times -2, well, that's a -6. Nothing else changed. So we got that +4, f of n equals. I'm going to write that f of n equals again because he's never going to change. And now I'm going to combine like terms. Well, -6 and 4 like terms. So -6 plus 4, well, that gives me a -2. And then that 3n didn't change. So my final answer is f of n is equal to 3n minus 2. Number 11, we have f of n is equal to 6 times the quantity n minus 2 minus 5. So I'm going to distribute that 6 to both numbers in the parentheses, or both terms in the parentheses. So 6 times n is 6n. 6 times -2 is -12. And then nothing else changed. We didn't distribute anywhere else, so everything else remains the same. And I'm going to, again, drop down that f of n equals because that's not going to change. Then I combine like terms, which, again, in this case, are these back two because they do not have a variable. And when you combine like terms, that means you just add them together or subtract them depending on the sign. So -12 minus 5, well, that gives us a -17. 6n doesn't change. It doesn't have a like term, so it just stays 6n. So my final answer is f of n is equal to 6n minus 17. Now I'm going to show you how to use the calculator way. Okay, so now I'm going to show you how to use the calculator way for numbers 9 through 10. What we're going to have to do is we're going to have to type that original equation into our calculator. So if you still have this page on your calculator, to get out of this or to change your equation, you have to hit this y equals button. Then, this isn't the equation we're using a new one, so I'm going to hit clear. And now I'm going to type in this equation exactly how I see it into my calculator. So -2, right? This is a subtraction sign here, so we don't use that. If it's in front of that first number, it's a negative sign. Parentheses, variable, which again will be an x, so don't freak out. It should be an x. And then we have +3, close parentheses, subtraction, right? We're subtracting that back 3. Double check everything's correct, and it looks like it is. I didn't make any errors. So now I need to open up my table. So I'm going to hit table. To get to my table, I have to hit the blue button, then the graph button. And we care about this right here, this first row where my top term here is a 0. That's what we want. That's how we simplify. So I'm going to write these out on my screen. So I have 0, and then we have -9. Okay. Now I can write out my equation. I have all the information I need to simplify. So we have f of n is equal to, and what you want to do is you want to copy that first number in front of your parentheses. So I got -2. Okay. Then we use just an n because our new table here starts with a 0. Remember, when it starts with a 0, it's just an n. And then its partner on the right here, we just copy that to the back of our equation, -2n minus 9. And this is our final answer. Now, if you're kind of like, why do we still use this -2? Well, if you look at your table here, the next row is 1, -11. Well, how do you get from -9 to -11? Well, if you think about this, it's getting more negative, so we're subtracting, and get from 9 to 11, well, that means we're subtracting 2. Okay, so that's another way to think about how you get that front number. Now see, this answer is exactly the same as the mathy way. So you still get the same answer as long as you know you do it correctly, type in your equation correctly, because that's really important. So let's look at this next guy here. We have f of n is equal to 3 times the quantity n minus 2 plus 4. So in my calculator, y equals, clear this, type it in exactly, 3 parentheses, variable button, minus 2 parentheses, plus 4. Now, before we go any further, if you ever get an error on your screen, it's because you might have used a subtraction sign when you're supposed to use a negative sign. So pretty much only this number up front for these particular problems will you use the negative sign. Everywhere else after that will be the minus button. All right, so we need to open up our table. So we have second table. We're using this row, 0, -2. So I'm going to copy that down here. So we have 0, -2. And now we have all the information we need. So we have f of n is equal to, remember, we are going to copy this front number exactly, 3n, and it's just an n because now our table here starts at a 0, and its partner in crime is this -2. So after that n, I write -2. And this is my final answer. Now again, this 3 you could also see from our table, table over here on the calculator, we have 1, 1. Well, how do we get from -2 to 1? Well, we add by 3. So that's another place that we can find that 3 if you don't remember that you just use this number up front here. And again, this matches what we did mathematically. Moving on. Last one, number 11. If you want to pause the video and try it on your own and make sure you know what you're doing, that would be good. So here we go. I'm going to hit y equals. I'm going to clear this. That we have 6 parentheses, variable, minus 2 parentheses, minus 5. Double check. Everything's good. I'm going to hit second graph to get my table. I'm using this first row here. So this first row we have 0, -17. Okay, copy down my equation. F of n is equal, we can now write our simplified equation. Copy this number 6. So we have 6. Just an n because our table starts at a 0. Then we write the partner in crime of that 0, which is a -17. And this is my final answer. That's simplified. And again, if you're not sure, if you can't remember that this is the 6 that you're going to use, just write down the first 2 rows of your table on your calculator. So we have 1 and -11. So think about this. How do we get from negative 17 to negative 11? Where it's getting less negative, so I know I'm adding by something. And 17 to 11, well, that's adding by 6. Okay, and again, this equation we found on our calculator matches the equation we did mathematically. All right, that is the end of our review. Very good luck to you. Remember to do your homework. Come to the homework help session that will be on Thursday at 11:30, or come to the reviews that will be on Friday. I wish you all the best of luck. Until next time.